Tonight's video is on section 5.5. This is bases other than E. So your homework for this section out of 5.5 is 37 through 67 odd. So I know I gave you a handout today with 31 derivatives and integrals that you had to memorize. You will be adding these three on today, and you'll be having a few more tomorrow to add on. So the first one, you take the derivative of a function, which is y equals a to the x. Take the derivative with respect to x. It would be the natural log of a times whatever this is, a to the x power. So let's do an example. Let's say it's y equals, so your a is your constant, and then your variable's up in the exponent position, 2 to the 3x power. So let's go ahead and take the first derivative. So it tells us to take the natural log of the base times what this is, and of course we're still not done. This is not just x, we have to do chain rule. So then we have to take the derivative of 3x, which is just 3, and then I rewrote it. 3 times 2 to the 3x times natural log of 2. The second new derivative, the derivative of log base a of x with respect to x. That would be equal to 1 over the natural log of a times whatever is here in this position, x. So let's do an example. So your function is y equals log base 10 of cosine of x. So let's go take the first derivative, right? Take the derivative of this. That would equal 1 over the natural log of 10, right, just the base, times whatever is in here, times cosine of x. It's all in the denominator. And because this is not just x, we have to now do the chain rule times the derivative of cosine of x, which is negative sine of x. So if I clean that up, there would be negative sine of x over cosine x, that's tangent of x over natural log of 10. And then we have one more that you're going to need for this unit. Sorry, for this section. The integration of a to the x dx. That equals 1 over the natural log of that base times whatever this is plus c, because it's an indefinite integral. So here's an example, 3 to the negative x with respect to x. How do I integrate that? So it's equal to 1 over the natural log of that base times whatever this is, 3 to the negative x. And because it is not just x, I have to times it by negative 1 plus c. So that would clean up to negative 1. And this is a negative exponent, so to make it positive, I'm going to put in the denominator, 3x, natural log of 3. So what is really going on here is I have a u substitution. I have a u substitution there. And a u substitution here. And a u substitution here. So let's go ahead and let's try a couple of problems. Number 41. I just want you to find the first derivative. So let's take that first derivative. Well, I have the variable here and I have a variable here. So there are two functions being multiplied together. So that means I'm going to have to do the product rule. Whoops. And so I'm going to take the derivative of this. So that would be the natural log of the base times all of this. And I have to do chain rule because this is not just the variable. So the derivative of negative theta is just negative 1. Times the second function, just the way it stands, plus, leave the first one alone, times the derivative of cosine pi theta, which is going to be chain rule. That's negative sine pi theta times pi. The derivative of pi theta is just pi. Oops, sorry about that. And let's go ahead and let's clean this up. So let's see, this belongs in the denominator. The whole thing is going to be negative, so negative, let's do cosine of pi theta times natural log of 2 all over 2 theta. Plus, let's see, this belongs in the denominator. Negative pi sine pi of theta. So I'm going to factor out a negative and the 2 theta. So negative 1 over 2 to the theta power is cosine pi theta times natural log of 2 plus pi sine pi of theta. Oops. Next example is going to be on the next page. Still the same direction to take the first derivative. First thing I'm going to do with this is I'm going to rewrite it. Let's see. No, I don't think I want to. I think I'm going to go ahead and just do the product rule. What do I want to do here? Let's rewrite this piece here. Let's do a side note. Log 4 of t equals, I can either write it as log t over log 4. That's what I would use if I want to put in my calculator. Or it doesn't matter if I use log, or it doesn't matter if I use natural log. So let's go ahead and take that piece and write it with natural log. 10 natural log of t times natural log of 4. So I took this and I substituted in for that, right? So let's go ahead and take the first derivative, and I'm going to go ahead and use the quotient rule. So the derivative of the numerator, so that's 10, and the derivative of natural log of t would be 1 over t times the denominator, t natural log of 4, minus, now I'm going to leave the numerator alone, 10 times natural log of t times the derivative of the numerator, and that's just a number, right? Natural log of 4 is just a number, so it's a number times t. So it's just going to be natural log of 4 all over the denominator squared. Now I'm just going to proceed to try to clean this up. So let's see what I can find here. These t's cancel out, so it's 10 natural log of 4 minus, well, we'll just leave that, natural log of t times natural log of 4. Might as well put parentheses around that also. T squared times natural log of 4 squared. You can take a natural log of 4 out. You can factor it out of the numerator and the denominator. I'm left with 10 minus 10 times natural log of t all over t squared times natural log of 4. Because this factored out, and I could cancel it with 1 in the denominator. what else could I do? I could factor out, let's see, the natural log of 4 can be rewritten as natural log of 2, which can be 2 natural log of 2 using the power rule. If I take out that 2, then I can factor a 2 out of the numerator as such. Okay, and I did that. And the last thing I could maybe do is factor out the 5. And this is what the answer looks like in the textbook. So I did do the first derivative here, and then I just kept on working on how could I simplify it? How could I clean it up? Those are just good skills to practice. I have another one for you. And this is, I'm actually doing your homework problems. Number 55. Now, this one here changes up the directions a little bit. It says to use log rhythmic differentiation. So they want me to take the first derivative, yes, but logarithmic, and there is no logs. So what that means when you see those kind of directions is they want you to go ahead and take the natural log of both sides. So I'm going to go ahead and I'm going to bring that down using the power rule. As such. Now I'm going to go ahead and I'm going to take the derivative of both sides, and obviously this is going to be implicit differentiation. So the derivative of natural log of y is 1 over y dy dx. And this one here I'm going to use product rule because there's a variable here and a variable here, so there's going to be 2 separate functions. So the derivative of the first function should be 1 times the natural log of x minus 2 plus, leave the first one alone, and take the derivative of the second one. So that's 1 over x minus 2 times the derivative of this, which is just 1 also. Right, that's what it looks like. So now I'm going to go ahead and I'm going to take both sides and multiply it by y, right? So I can isolate the dy dx, which means my first derivative. I'm going to go ahead and just rewrite this. And I need to substitute in what y is, which is my original function. Oops. Whoops, 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 whoops. Okay, let's try this again. Jeez. Times my y. Okay, right, there's my y up there. Substitute in y for the y. And actually, in the textbook, they leave it like this. Awesome. We'll do that too. I'd like to try one more. And this is some integration. In fact, I'm going to do your very last homework problem. So you're supposed to integrate it, and this happens to be a definite integral because it has an upper and lower bound. So I'm going to separate this. And so we have that new property. So this one here is 1 over the natural log of whatever the base is times this whole thing minus, same thing, 1 over the natural log of the base times this whole piece. And because it's just x, I don't do the u differentiation, so I'm going to put, I don't put plus c. It's from 1 to 0. Before I do that, I'm going to go ahead and clean that up a little bit. And I think I'll go ahead and proceed. 5 to the first power right, so I used 1 minus so that's just 5 over natural log of 5 minus 3 over natural log of 3. What is that? That's a 1 minus 1, 1, correct? Let me distribute that negative. Combine like denominators, right? Combine those fractions. So it's 5 and a negative 1. That's 4 natural log of over natural log of 5. And then a negative, let's see, so that's a positive 1 and a negative 3, so that's minus 2 over natural log of 3. Thank you.